like say this one, I can write is like D equal to A, B, C, Y equal to D bar. The same line I can write in 2 lines. First A, B, C, I copy in D, and then D bar copy in Y. Right? Sometimes we can write like this. So like this. So wire N1 means this is a local variable like D. So this is a wire. This is a new wire. Name is N1. Okay. Now N3 is a kind of, you can say, a module. Module N3, and you are declaring this gate with your name and gate. ABC is your input. This input ABC. Output is N1. Okay. You understand? Output will copy here. Then this is like you want to calculate ABC and store in D. Then you will invert D, copy in Y. So this D is here N1. Okay. So you N3 means this module, first module, and name of the module here, name of the gate here, your gate of type N3. Okay, N gate, you give ABC, the input you get here ABC, and you need the output in N1.
Why?
Local output.
Why write Y?
Why don't I write Y?
Yeah, yes.
Because Y I will change it here. Okay, so you give it N1, so as if you will call this N3, it will calculate A and B and C and return the value in N1. Then you can call or make another gate of type INV, inverter, with name inverter. Input you give this N1 here, and output will come in Y. Why I don't write bar here? No, you mean without using this Y equal to bar N1? Is it your question?
Yes, because now it is a bar.
Yes, yes.
For what?
First we calculate N.
Yes.
Here. Then we calculate the bar. This
Yes,
inverter will calculate you the bar.
Yes, yes.
So after you calculate the N,
You calculate the bar.
we calculate the bar here.
But,
So?
not important to write bar.
Where? Here?
Yes,
Here?
yes.
Why I write bar? I need A and B and C. A and B and C. A and B and C. A and B and C is now in N1.
Yes.
So I need to send N1 as input here, right?
Yes.
If I send a not here, you will get actually wrong result, right?
Yes.
You don't understand? This line will give us N1 equal to A and B and C.
Okay.
This line. And this line will calculate Y equal to N1 bar. This line will calculate N1 equal to A and B and C. And the next line will calculate Y equals N1 bar.
Okay.
Using this module.
What's the comma in the last comma?
Yeah.
What's the last the comma in the last line?
Here,
Yes.
it's semicolon.
We should.
Here, this, you mean this part? This is comment. This is comment. Say internal signal. This is internal signal. It is instance of N3, and this is instance of inverter. Do you understand instance? Instance means copy. The copy. Like you make a gate here. Like you make a gate here. Suppose you make a gate here. Here. I need a copy. So like I have a copy machine. I make a copy, I give you. I make a copy, I give you.
They give a name from my mind
Yes, yes. And that copy, to differentiate between different copies, you need to give name to the copies, right?
Yes, from my mind.
Yes, from your mind. Yes, yes. These are from your mind. Yes. AND gate, inverter is your mind. But this N3 should be same as this N3 because you are making a copy here.
Yes.
You made a gate, you are making a copy. So which kind of gate? This kind of gate. Which kind of inverter? This kind of. So this INV should be same as INV. If you write here INV 2, you should write here INV 2.
Why not write bar here? In bar.
Here N bar. Not in N bar here. You mean don't use this?
Because this
Inverter, yes.
for this.
For this, yes.
Yeah. Why not write bar?
Here you mean without just write here y equal to N1 like this?
No. Yeah.
Huh?
Yeah.
You mean this question? Yes, yes, you can write like this. Without using this 2, you can write everything here. No problem. You can write everything here. This example is showing how you use modules, other modules inside your module. This is the example. Do you understand?
I call functions.
Like how you call functions.
Yes.
Without these two modules, these two lines, if you write here, it will do the same thing. You understand?
Yes.
If you don't write these two modules, you copy this line and this line here. It will do the same thing. But this example is to show you how you use modules in your program.
Yes.
How to use modules, like how to use function in a C program, to show you.
Yes.
But you can write a C program without any function.
Yes.
Everything write in the main.
Yeah.
No need to write a function. Right? But we write module or function so that you can use many times. You can use it many times. This is the way we write modules. Otherwise, you can do everything in the same function. You understand?
Yes.
Okay. Now, here we list what are the bitwise operators. Okay, bitwise operators. This is AND. This is AND. This is OR. This is this cap is XOR.
This cup?
Cap. It has other names, I forgot. Anyway, you know this symbol, it's in keyboard. In your keyboard, you have this. All of them you will find in your keyboard, okay? In your keyboard, all of them. This is XOR. This one is doing NAND, right? A and B, they are not. This is NAND. A or B with not. This is not or. A or B with a not or. So this module gates will calculate different bitwise results. Just a dummy for you showing examples. It is not a very useful thing.
Yes.
Just showing you how to write. So module gates input AB, but there is something extra here. Can you see? See, in here there is nothing. Input ABC. But here you can see input. There is something like this. 3:0. Same here. Output 3:0, Y1, Y2, Y3, Y4, Y5. So what is the meaning of this part? Can you guess? What is the meaning? Idea? Yes. No idea. What do you think?
I think it have 5 results.
Yes, something similar. Yes, good. It means
From 0 to 4.
0 to 4. Yes, it has four lines. I told you that in hardware sometimes we write like this. Yes. So this one means actually you are giving 4 lines. You are giving 4 lines and say A0, A1, A2, A3 like this. So this one means input this A. This means I have 4 lines A3, A2, A1, A0. This means this. This is the meaning of this line. Meaning of this line. That we have 4. This is 4 bit. This is 1 bit. A is 1 bit variable. Okay. But here A is 4 bits. So this means A is 4 bits. Okay. The leftmost is A3, A2, A1, A0. This is the meaning of this line. The first one is A3, then A2, A1, A0. Okay. Same for this line. So here A is 4 bits, B is 4 bits, Y1, Y2, Y3, Y4, Y5, all of them are 4 bits. Okay. So here assign Y1 equal to A and B. So 4 bit and 4 bit will result is 4 bits. So say A is say 1 0 1 1, B is say 0 1 1 0. Okay. Then Y1 equal to A and B. What is the result of Y? What is the result? Y1 equal to what?
1 0 1 1 0 1.
Y1 will be
1 1 0 from
left, right, no problem.
0 0 0 1.
0 0 0 1.
0 0 0 0 1 0
1 and 0. This means each
Zero.
bit will be AND.
0 0 1
This
0.
means each bit will be AND with each bit. So 1 and 0. 0. 0 and 1. 0. 1 and 1. 1. 1 0. So Y will get this value. Do you understand?
Yes.
So this is the meaning of AND or XOR using more than 1 bits. Each bit will be separate, but the result will be 4 bits. If you do it for say XOR, what will be the result? This line, XOR.
XOR
Y 3.
1 1 1
A
1
XOR B.
1 1 1 1
1 1
1
1 1 0
1
1.
1 0. 1 1 0. Remember,
Yes.
XOR
yeah,
will be
yeah.
0
1, 1.
if both same.
Yes, yes.
XOR will give us 0 if 2 bits same. So 1 0 give you 1. 0 1 will give you 1. 1 1 will give you 0. 1 0 will give you 1. So in this way, Y1 will be 4 bits, Y2 4 bits, Y3 4 bits, Y4 4 bits, Y5 4 bits. Okay? This is bitwise operator. Bitwise means each bit separate. This is called bitwise. If you give 4 bits, this 2, then this 2, then this 2, then this 2. But binary addition is not bitwise. You understand? If you want to add them, it is not bitwise because you have carry, right? Remember? Carry. 1 plus 1 is 2. So 1 will go.
Yes.
So addition is not bitwise. The normal addition is not bitwise. But and or they are bitwise. Do you understand the difference? If you want to add these two numbers, say if you want to add 1 0 1 1 0 1 1 0. If you want to add plus 1 0 is 1 1 1 we have 0 with a carry 1, right? So that means it is not bitwise. These 2 bits will give extra bit here. So 1 0 1 again a 0. You get a 1 1 1 0 1. See, you get extra bit. 5 bits. Overflow something. But here result is always 4 bits because it is bitwise. There is some addition which is actually same as bitwise, but it is called modulo arithmetic. Modulo 2.
Victor, how we get A and B? 1 0 1 1.
Every input you give any value. You give, it's an input like circuit. When you give circuit input by value like this, you give A and B as input. Any value you can give. Here I am showing what if you give A this and B this, what will be the answer? This is the I am showing. Clear? Yes.
About the output,
Yes.
it's not should be start from Y0 because it's 0 to 3.
Sorry, I do not.
About the output.
Output this
It's not
output.
Same. No, the first.
Yes.
Yes, this one. Not should be start with Y0, then Y.
No, these
Or
are
just
5 outputs. This line means Y1, Y2, Y3, Y4, Y5 are 5 outputs. Each output is 4 bits. Like here, you can see the diagram by the software. If you see the diagram, see, it's not very clear coming here, very clear, but this is your A and B, 4 bits, 4 bits, here 4 bits, 4 bits, but if you look at the slides, it's more clear. 4 bits, and this is the circuit they do, and not or, and you can see here 5 outputs, and each of them is 4 bits. So first one is, let me see, Y330. This is Y3. Okay. So this is a here actually 4 bits are coming. 4 bits. Okay, 4 bits. Here 4 bits, 4 bits, 4 bits, 4 bits. But how many outputs? 1, 2, 3, 4, 5. 5 outputs, but each one has 4 lines. 4 bits means what? 4 lines are coming. Do you understand? Think about real circuit.
4 lines in one output.
Yes, 4 lines in one output. Yes, like this is a gate. Say I have an OR gate. 4 means what? Here actually 4 wires will come. As output, 4 wires will come. Okay. Very good. Pictures are very bad coming here. Okay, here another shortcut called reduction operator. Say we want to design an AND gate with 8 inputs. We want to design an AND gate with 8 inputs. Very big AND gate. So that's why input is A, but from 0 to 7. Huh? So you have A7, A6, A5, A4, A3, A2, A1, A0. 8 lines coming. And if you want to AND all of them, then you should write a line like this, right? Assign Y equal to A7 and A6 and A5 and A4 and A3 and A2. Big line. Okay. There is a shortcut in Verilog where this big line you replace with this small expression. Okay. This big line and this part same. They will do the same thing. You understand?
Yes.
So you put A and before it you put the M. Okay, not after. Before it.
Why put it and?
If you want to do this thing. Say if say I have B, say B5, B4, B3, B2, B1, B0, and I want to do. So without writing this big line, I will delete it, select and delete, and write. Yes, just this.
If you want to order.
Order. Yes, there are others. Yes, you can do similar things. Okay, we will see. Inshallah, we will see. So module and 8. Like
There
this.
are two way.
Yes, either this way or other way. Either you can do this or do this. And if you generate the circuit, it will look like this. This part is not clear. It's like a simple end. Here there is the end gate. Okay. Like eight inputs together, send, and output is 1. How much time do you have? Let me see where I want to go. Okay, let us see this again. Remember mux? Mux? What is the mux? Remember mux? Two input mux. So 2:1 mux. We want to write the code for mux. Multiplexer. Remember multiplexer? This is select. Say A, B, so 0, 1, output is Y. This is 2:1 mux, right? So if you give select 0, A will go to the output. If you give select 1, B will go to the output. Multiplexer. Remember multiplexer? Forgot? Who forgot? Remember? Yes. Remember I talked about this road, two road, a traffic police there with a flag, go you, go you. Same thing, it's traffic police, two road, but in the front only one door. So he will say, go you, go you. So how can we design a mux using a code? So actually for this one it is very easy. I think those who took C, you took this ternary operator, right? Did you take ternary operators in C? This one? This A. You did not take this one? Okay. So here you can see module space
This is name.
name of the module mux 2 input mux. So we give a name mux 2. Input is
3 bit.
4 bits D0 D1. So here we have
D0.
D0 D1. Okay.
What?
Output, this is 4 bits, this is 4 bits. Okay. And output is
Four.
Y.
4.
It is also 4 bits.
Yes.
And select bit is your S. Right? So for this circuit, this is an input, these are also input, right? And you will get an output. So here, what this input is a single bit, right? Either 0 or 1. And these two inputs are each one 4 bits. D0 4 bits, D1 4 bits. So if you give S equal to 0,
Take 0.
D0 4 bits will come to the output.
Take.
If you give S equal to 1, the 4 bits in D1 will go to the output. Okay, it's more general. So that's why we have input D0, D1. Each one is 4 bits. And also we have another input called S for select. Okay, and output is 4 bits. Y 0 colon 3 colon 0 within a bracket, square bracket. Now here you write the multiplexer function. Okay, how? There is a ternary operator. Ternary operator. It is also in C. Exactly same operator is also in C. In your C book, search ternary operator. You will find this. Same, exactly same. Also in Java. Maybe you did not learn in the class, but in your book it is there. So assign y equals S, then a question mark, D1 colon D0. What is the meaning? The meaning is, if S is true, y will be same as D1. If S is false, y will be same as D0. This is the meaning. Do you understand? If S is true, y will take the value of D1. If S is false, y will be same as D0. So for our case, S true means S equal to true means S equal to 1, right? So if you give S equal to 1, y should be same as D1. That's why when S equal to 1, here we have D1. But if you give S equal to 0, y should be same as D0. That's why if S equal to 0, you give S equal to 0 here, then y will be same as D0. So this simple module will implement this mux. Okay. So here let me see the diagram. Okay, it is very simple. It's like okay, this is S, this is D0, this is D1, and here you have Y. Okay. Just one line, you finish the mux. You made a mux. Okay. So it's called ternary operator, same as C. So inshallah we stop here. Inshallah next class we will continue.